This video here contains a few notes related to your exam project in KE803 molecular modeling. Some very practical stuff here is that the submission deadline for the project is December 15th before 12 o'clock, but you are of course welcome to hand in your project before this deadline. You can either email me the projects at my email address given here, or you can drop by my office and give me a version of your project. The 18th of December you will have your projects back, and it works in the way that this day you will drop by my office and then you will have your projects back on an individual basis and you will get some feedback on your project. Before you begin working on your project, you will have to write a short synopsis of your project, around 5 lines, and give this to me. Once I have approved this synopsis, you can start working on your project. And the deadline for handing in the synopsis is November 10th. In the synopsis, you explain very briefly what you are going to do in your project and how you are going to do it. You can either work out these projects here completely individually, that is a one-person group, then the project report should be up to around 10 pages, or you can work them out in groups consisting of up to 2 persons, and then the report should be around 20 pages. If you work out your project in a 2-person group, then you must include a description on the specific contributions from person 1 and person 2. And this is very important, and is due to the fact that of course we have an individual evaluation of these reports here. Also, remember to include references in your project. Now, when evaluating your project, I put emphasis on the fact that you are able to argue why you have chosen a specific theoretical method to carry out your investigation. I do not put that much emphasis on the fact that you were able to actually reach to some numbers that shows some good performance in the end. That is, if you are able to solve your problem using the computational method, simply because I'm aware of the fact that we only have a limited time available in order to carry out these projects here. But I do put emphasis on the fact that you can argue why you choose the specific theoretical method and that you really show in your report that you know what you are doing. Now, when you build up here your report here, then you can follow the conventional way of building up such a report by an introduction. Maybe you will have to have some notation abbreviations included. Then you give a description of the theory that you are going to use, why this specific theory is adequate, and a description of the theoretical method. Then in the results and discussion section, remember to have some nice and illustrating figures, and also remember to collect the numbers in tables. You have a conclusion and a list of references. Now try to make this project a nice read here and try to use this as an opportunity to do a small mini research project and to write it in the form of a mini research report. Now, in class, I will be bringing with me, when we discuss the projects, examples of previous projects that you can look in and that you can be inspired from. A few suggestions here to projects could be MD simulations of larger molecules, DNA, RNA strings, etc., proteins, ligand binding processes, docking of ligands. In ab initio, we could study different kind of reactions, addition reactions, SN2 reactions, transition state investigations, calculation of electronic spectra, and so on. And of course, you could do combined investigations where you both do some modeling followed by some ab initio calculations. Specific projects here could be, for example, calculation of the equilibrium constant for some keto-enol tautomerism, calculation of NMR spectra, specific versus implicit solvation effects on absorption spectra, ozonolysis, and stability of water clusters, and many more different topics can be investigated in this course here. As said, in class I will bring some recent reports that you can use for inspiration.